Okay, now I'm going to look at part C of the Hungry Mouse problem. And part C asks us to graph the position of the mouse versus time. Okay, so if I want to graph the position of the mouse, I'm going to need to have a graph, and I happen to have one ready for a graph of the mouse motion. Okay, so this is my mouse motion graph. And I know that he traveled 30 meters, so I'm going to say on my x-axis, which remember is a little bit strange in math class. You normally put the x-axis down here. Well, in physics, you normally put time where the x-axis would be. So time goes down here, and then distance goes here. So distance, I know that he went a total of 30 meters, so halfway there would be 15 meters. And he started at 0. And so I have it labeled x in meters. The time, on the other hand, well, we know it took him 30 seconds to do the whole trip. So if this is 30, let's see, that can be 20 and that can be 10. So this is going in units of 5. So 5, 10, 15, 20, 25, 30. Okay, and now I'm ready to graph. So I know that the first 15 meters, it took him 20 seconds, and he was going at a constant rate. So it's going to be a straight line. So make sure I get the right point here. So if this is 15 meters right here, there's 15 meters, and there's 20 seconds. So I'll put a little dot right there, and now I'll connect the dots. So he started at 0 meters at 0 seconds. There we go. Okay. And now the second part of the motion from 15 meters to 30 meters took him 10 seconds. So we know that he ended up over here at 30 meters, and it took him 30 seconds, so I'll put a dot there, and then I'll connect the rest of the graph here. Okay. So there is my graph of the mouse motion. So you can see how there's really two distinct parts to the graph. There's the part from 0 to 20 seconds, and then the part from 20 seconds to 30 seconds. And you can see how the line is a bit steeper here. That means he sped up. And let's just check the question, graph the position of the mouse versus time, and that's what we did.